Finally, the Cij is supposed to be the alpha 1. So if we go back to the cell, the alpha 1, we paste it down here. Ether water is, okay, I'll write here. Ether is this row, water is this column, is 0.2223. They're the same numbers in here. This is why this is just one. So the 0.223, if you cut and paste, you have all the trees there, in case it makes a difference. So I cut and paste the 0.223, control copy, control V. So we define the parameters of one of the 3 binary pairs. We also have acetic acid water and acetic acid ether. So let's create the other 2. Click on an empty column. Everybody has that? Put it more time. Okay, good. All right. So I click in the next column, and let's choose acetic acid. And notice the moment I choose that, give me another column. And second component, what? And of course, this is user. It will become user the moment. You can see here choices. I think you have only. Yeah, users have 2 choices. Okay. All right. Are you guys seeing both choices? Yes. Okay. All right. Okay. So, acetic acid water. I is acetic acid, J is water. So, normally raw acetic acid water, but no, remember that I becomes the second component here. So the rho is the second component. So the second component that is here, J, becomes rho here. So minus 110 goes to be acidic water. So I'll put that here, and I'll put this here. Right. So the minus 110 user automatically fills the rest with 0, and the AIJs are indeed 0 for this, so we can leave it. Okay, so the transpose, the 424, control copy, goes in this position, and the alpha 1, with that pair, the 0.2997, goes in the Cij position. So that's what you should have this. One is more time. Good. Next one, we need just one more. We need ether water. We need acidic ether. So click, acetic acid, and ether. But one thing I wanted to point out, make sure you have the same system of units between Aspen and Unison. Do I have SI units in Aspen and in Unison? Let me quickly check. Okay, kilograms, everything, yes. I have SI units. Please make sure of that. I'm glad I remembered that. Very important. Have the same system of units in both. All right. Let's go there. So for the third one, the third one, the order I have there is acetic acid ether. So there are these two values. So acetic acid is first. So acetic acid ether, I will get the IJ with acetic on the column and ether on the row. So the IJ is the 84, and the 317 is the JI. So the 84 goes here. And 317 goes here. And the last thing is the alpha 1 goes in the C position. Control copy. Control copy. So these are the parameters, and I've entered a lot of values. What should I do at this point?
Save.
Save file. I'll save it as this. And always compound file this. So save this compound file. I'll call this compound save. All right. Okay? Anybody needs more time? Next thing, let's click. Click under analysis where you see the three plots, ternary diagram, not the residue curve. I think last time I clicked residue curve, really we should choose ternary diagram. So click ternary diagram. Takes a bit of time. And use distillation synthesis ternary mass.
It's not letting me select anything for ternary diagrams. Like it's shaded out, so I have to
Did you click? Okay, click analysis first here, and then analysis here. And then we select the third choice. Yes, use distillation. Because that's the one that gives me what I want. We're going to be using this for distillation design. So that's the ones we need. Say again? I don't know, Celeste. During the break, I can try to find out. But how many of you are seeing this problem? How many of you are not seeing what I'm seeing? Okay, let's wait until the break. All right. Right here, and we're on the input screen now. On the input screen, you can specify things like the order of your components and whether you're going to have mass fraction or mole fraction diagrams. What unit you're going to use for pressure. And we will discuss between the choice between residue curves and distillation curves. We will define those concepts later in the class. We're not ready for that now. Leave those checked. This is my first experience with Aspen version 9. I just installed it yesterday. But I know that all previous versions I had tested were buggy with respect to one aspect. Okay, let me show you a plot first. Okay, so click ternary plot. You have to be patient. All right. So, are we seeing this one? Other than Celeste and maybe Oriana. But out of the two of you, is everybody else seeing this one? All right. You have the choice of triangle, right triangle, that's the one I normally like. And what you see in this diagram is it shows superimposed the two-phase envelope. Here you have the components, this is acetic acid, so this corner is pure acetic acid, diisopropyl ether, so here's pure isopropyl ether, here's pure water. We know ether and water are not completely miscible. As a matter of fact, they're almost totally miscible, but so clearly this is not very good. Okay? You expect that envelope to be a lot larger. The other thing you see here is this line. This line is a distillation boundary. According to these parameters, and it's not necessarily correct, according to these parameters, there is an azeotrope between acetic acid and water at this composition. We see the triangle. And there is an azeotrope between water and ether at this composition. And the two azeotropes are connected by this distillation boundary. Something we're going to be doing quite a bit of later is generate curves that help a lot with distillation design. And you have a choice of either distillation or residue curves in the input. You specify which of the two you want, but let me show you something. I'll click. You have a choice here. You can specify things either by specifying a location or by just clicking at a position. So, if I take this curve, click this, and click it here, you see a certain curve generated. Let me click it several places. These are so-called residue curves. They show the path that ordinary distillation would follow if you have a batch of Rayleigh steel. Notice that in this region, all those curves start from here, and this azeotrope has the lowest boiling point. Here you don't see the boiling points of the pure components, but the arrows show which way the composition moves as we boil up. And the sink here, pure acetic acid, is the highest boiling point. So anything in this region basically ends up here. Anything in this region ends up on water. If I click on this region, you see the lines going all towards water. So what you see here is a distillation boundary. So that's going to be a very useful tool when we do the actual column design.
But did you say the green arrow, the green dark arrow is the distillation boundary, or the blue? The dark blue.
Green.
Blue.
Line.
Blue, distillation boundary is the green. Okay. We can place any point we want here by giving it an address or by just clicking on it. Let's see where the composition of the feed to our decanter is coming. So if you recall, our decanter had 10% acetic acid. It had 10 kilograms per hour acetic acid, 30 kilograms per hour ether, and 60 kilograms per hour water. So in terms of mass fractions, the compositions are 0.1, 0.3, and 0.6. So I want to change this diagram to to be mass fraction since I have my compositions in mass fraction. So I'll go back to the input, go to Explorer, input, and I'll change my units from mole fraction to mass fraction. And if I go back to the plot, now you see the plot change because it's mass fraction. Very interesting. Notice how the envelope has all gone up here. It's a tiny two-phase envelope. So where was our point of the feed? Our point of the feed was, so we create a point. I will click for a point with, if you see the eye, that means I give coordinates. So acetic acid is 0.10. Underneath. Ether was 0.3. And you have to enter also the water. It doesn't go. Oh no, actually it doesn't. Okay. And click OK. And you see now a point here. Right here the circle. So this is where our feed was. It's not in the two-phase region. Is there any wonder that the model predicted that there would be no separation, that everything basically, our decanter became just a mixer? Now, we have other choice of parameters. Let's, for example, so let's see, wait a minute, because you're doing this as homework. So we translated the parameters to Aspen Plus. Let me quickly go to them.
Could you add that point one more time?
Go to I.
Sorry, let me go here first. Translate the unity parameters to Aspen Plus parameters by transposing Aij and Bij and using the values of unisim Aij for Aspen Cij. Generate and print a ternary phase flow diagram using Aspen Plus. This diagram you need to print. So if you don't have a printer here, you can capture it. For example, control print screen, right? This is in microdoses. How do you capture? Microdoses, you know how to capture a screen, right? So capture this screen. Yes.
How are we supposed to do this as homework if not everyone can use Aspen?
So those of you who can't use Aspen, as I said earlier, hopefully friends and teammates have Aspen, and just for this part, you can do it on the. Okay. There will be no exam problem involving Aspen or HYSYS, but okay. This is the only homework that has Aspen. There's also the last homework that has HYSYS. We'll see how many of you have been installing by then. All right. So get a screen capture of this. All right. So we can do several things. We're going to change the parameters after we took the screenshot. Okay, number 4. Oh, and by the way, yeah, what parameters it finds, I think it's a bug. But all versions of Unity and Aspen have been doing it. Changes according to how you have ordered those, and I didn't order them this way myself. So when we go back to Unison, we'll change the ordering of the 3 components, okay, to have them in this order. And we'll generate some parameters in Unison, put them back in Aspen, we'll see what happens, and we'll put them back to Aspen Plus, and we'll see what happens. But, so I'll do something now that is not part of the homework. Let's check what happens with parameters we have from Aspen Plus. Okay? So I'll go back to the NRTL screen. Oh.